The treatment of ALS, amyotrophic lateral sclerosis, is changing in a big way. For a disease that once had so few options, science is now lighting a new flame of hope. Today, I'll walk you through what's happening at the frontier as simply as I can. I speak to you as a dentist who also lives with ALS. First, what kind of disease is ALS? Throughout our bodies runs something like electrical wiring, carrying commands from the brain to the muscles. We call this wiring the motor neurons. In ALS, this wiring gradually loses its light. So even when the brain says move, the hands, the legs, the ability to swallow, and eventually the muscles for breathing, stop working the way we want. For a long time, all we could do was watch this wiring fade. But now, science holds two kinds of magic. One is to repair the genetic blueprint. The other is to restart the cells themselves. We are trying, once again, to relight a fading flame. Let's organize the hope, now moving forward into 4 pillars. First, drugs that precisely target the gene. Second, a way to find effective drugs using a patient's own cells. Third, early treatment that makes time our ally. And fourth, the artificial intelligence and regenerative medicine that support it all. Let's look at each one. The first pillar, targeting the gene. In some types of ALS, there is a kind of typo in the body's blueprint, which keeps producing harmful proteins. A new class of drug sticks to that faulty blueprint, working like a correction fluid, and stops the harmful protein at its very source. It is already being used overseas for certain types, and drugs for other types are emerging one after another. But how do we know a drug is working? The key is the smoke that rises from the nerve's fire. When nerves break down, a marker leaks into the blood. That is the smoke. If treatment makes this smoke decrease, it becomes indirect proof that the fire is calming down. We can now confirm invisible change with numbers. The second pillar, finding drugs in cells. Researchers take a patient's cells, turn them into special, rejuvenated cells called iPS cells, and recreate tiny nerves in a dish. Then they test more than 1,000 existing drugs, one after another. It's almost like time traveling inside a test tube to find a cure. This is how ropinirole, originally a Parkinson's disease drug, was found to possibly help ALS. Further research is now awaited. The third pillar, making time your ally. Even the finest drug can only work if there are nerves left to protect. That's why noticing early and starting early matters so much. In fact, sudden weight loss can be an important sign that ALS may be hidden. High-dose vitamin B12 therapy, developed in Japan, has also been shown to work better the earlier it begins. Time, truly, is nerve. The fourth pillar, supporting all of this, is artificial intelligence and regenerative medicine. AI reads through vast amounts of research and proposes new drug candidates at astonishing speed. In regenerative medicine, iPS-based treatments are approaching practical use under Japan's new framework. The pace of development is entering a completely different dimension. But there is one thing I want to say calmly. Sadly, there are treatments that claim results without solid evidence. Before you pay a large sum of money, please ask your doctor whether it has truly been proven by proper research. Telling real hope from false expectation, that, too, is an important strength when facing this disease. Finally, what I most want to tell you. ALS was once called a disease of despair, but now, it is becoming a frontier where science and hope meet. Repairing genes, finding drugs in cells, protecting time, and AI giving it all a boost. And above all, noticing early becomes the greatest power. Please, hold on to hope. Together, let us walk onward. Thank you for listening.